Alright, what's up everybody? I'm back with another video, and today we're going to cover the topic of identifying any hazards and fixing them in electrical circuits. So we're going to go through this problem, identify all the hazards, and then write down the final expression that is containing no hazards. Okay, so here we have an expression A plus B A bar, C plus A plus C bar B. Okay, so if we have any knowledgeable hazards, there's four main types of hazards that we're going to look for. So we're going to create a little chart here, I guess. So we have static 0, right? And then static 0 is known as x bar. So if we get the final ending to be x bar, then we have a static 0 hazard. Then we have another hazard called static 1. Static 1, this is known as x plus x bar, right? So we have, for example, A plus A bar, B plus B bar. So we have x plus x bar. We're looking for this as a static 1 hazard. Then we have dynamic hazards, and there's two types of main dynamic hazards. So the first one is x ANDed with x plus x bar. So this is the first type of dynamic hazard. And the second type of dynamic hazard is x plus x bar. So these are the four types of dynamic hazards, or dynamic and static hazards, that we're going to be looking for while completing this problem. Now, it's important to realize that if we have variables here such as A and A bar, these are two separate variables. So one is independent from the other. So we can't ever treat them as the same. And it's important to know, if you guys don't already know, that A bar is just the opposite of whatever we tell A to be, or B bar is just the opposite of whatever B to be. So for example, if B is equal to 1, then B bar is equal to 0. Or if B is equal to 0, then B bar is equal to 1. So the bar variable is always the opposite of what the initial variable is. So that's important to remember while we get into these problems. Okay, so now let's start and let's get to the first step. So if we write down our equation again, so we have, let's write in green. So we have A plus B A bar ANDed with C plus A, ORed with C bar B bar, I believe. Okay. Oh, sorry, just C bar B. Right, so this is our equation. So let's get started with that. So first, when we're doing static and dynamic hazard problems and we're trying to identify the hazards, we have to first choose a variable to start off with that we can choose to be either 0 or 1. So in this case, you can really find the answer by choosing with any variable. But in this case, let's start with B, because we know that B typically, I would say maybe 80% of the time, will not have a hazard. And the easy way to notice that is, you know what letters usually have a hazard is if there's a normal variable and also a bar variable in the same equation. So as you can see here, we don't have any B bars to go with the regular B, but we have A and A bar, and we have C and C bar. So based off an educated guess, we can assume that our hazards have to do with A and C. Those are where the hazards are going to occur from. So because we don't think B is going to have any hazards, let's start off with B. So let's go here and let's do, what is this equation going to become when B is equal to 0? And what's this equation going to become when B is equal to 1? Now let's start with B is equal to 0 first. So when B is equal to 0, this becomes A plus 0 A bar, and anything with 0 A bar, this whole term will go to 0, because anything ANDed with 0 just becomes 0, correct? So we have A plus 0 A bar if B is equal to 0. So then this becomes A, just A by itself, because this whole term right here, it gets canceled out. So we have A for the first bracket. For the second bracket, there's no B here, so we just keep it the same. So it just becomes A C plus A. So this doesn't change because it does not get affected because there's no B within it. Now for the next part, we have plus C bar B. When B is equal to 0, it becomes C bar 0, and anything ANDed with 0 just gets canceled out. So this term is irrelevant. So this is what we're left with. We're left with A, C plus A, and then we can determine from this that there's nothing else to do. Like, no way you spin it, there will be no hazards here. No hazards, because like I said, we only have hazards when there's a variable and there's also the barred variable in the same equation. So we have the same A here, but there's no A bar and there's no C bar in this equation to match the normal variable. So we can determine that there's no hazards present in this equation. Now for the next one, we're going to do what happens when B is equal to 1. Now when B is equal to 1, we get A plus 1A bar. Now 1 AND with A bar is just A bar. So think of it as multiplying. What's 1 times A? It would just be A. So we're going to get A plus A bar here as the B is 1. So when B is equal to 1, our first one is going to be A plus A bar. Okay? So you have A plus A bar in the first bracket. For the second bracket, we have C plus A. There, once again, there's no B present, so it does not get affected. So we just have C plus A. Now for the next part, we have C bar B. And we have C bar, basically when B is 1, it's just C bar times 1. So it's the same thing as we did in the first bracket. It will just be 1 times C bar. So it's basically just C bar. So we're going to OR it with the C bar. So that is when the B is equal to 1. So now we have a whole new equation. So if we go down further with this new equation, we're now going to try things again. But this time, we have to choose a different variable. So we can either go with A or C. Regardless, we're going to have to do both to test them both out. But let's start with C first. So let's start with C. So when C is equal to 0. And then when C is equal to 1. So let's start with C is equal to 0. What kind of equation do we get? So when C is equal to 0, we get A plus A bar, so that doesn't change, but it's important to remember that this whole term is ANDed with the next bracket. So this is an AND term, right? Like over here, this is an AND section. So if we see this, we have C plus A. So we get 0 plus A, and anything ORed with 0 gets canceled. And because this is ANDed, this whole term gets canceled, if that makes sense. So we have 0 plus A, and then that ultimately becomes 0. If it's 0 plus A, that becomes 0. And then anything 0 is ANDed by, this whole term becomes 0, right? So if it was like we did before, the same rule applies. So then this whole section becomes 0, so it's irrelevant. Then if C is equal to 0, if you remember in the beginning of the video, C bar is just the opposite of whatever C is. So all we're left with is C bar, as this term gets canceled out. So then all we're left with is 1, because the C bar becomes 1 as it's the opposite of C. So 1 is the final answer we get when C is equal to 0. So we can also write down that at this point, there's no hazards. Oops, let me just change the color back. So at this point, we can also write down that there's no hazards. Right? Now, for the next part, we have C is equal to 1. Now, what happens when C is equal to 1? We have A plus A bar, and then C plus A. Now, when C is equal to 1, if we don't already know our rules from electrical circuits, when C is equal to 1, we get 1 plus A, right? So if we can write right here, we get 1 plus A. And anything ORed with 1, the whole term gets canceled. But if it's ANDed with something, it just becomes 1. So the 1 plus A is just equal to 1. So ultimately we get A plus A bar multiplied by 1, which is just A plus A bar, right? It's just any basic math rule. So the 1 plus A, anything ORed with 1 just becomes 1 automatically. And it's different because if it's ORed with 0, the whole term gets canceled and becomes 0. So then it would be A plus A bar times 0, which would then be 0, if that makes sense from basic math rules. So when c is equal to 1, we know that the 1 plus a, the c plus a becomes 1, and it gets ANDed with a plus a bar, so it gets multiplied by 1, so we get a plus a bar here, right? Now we have plus c bar. Now from the beginning, we also know that c bar is just the opposite of c. So if c is 1, that means that c bar has to be 0. So then plus 0 would be added, but this 0 is irrelevant, so we don't really need it, so we can just take that away because 0 does not affect our equation at all. So we can just take that away. So all we're left with is a plus a bar. Now, if we go back to the beginning, we can remember that a plus a bar is the same as x plus x bar here in the second one. So we know that x plus x bar is the same as a plus a bar. So we can determine that this, in fact, is a static 1 hazard, right? This is static 1 hazard. So if we go through the steps it took to get here, we can say that to get this static 1 hazard, b is equal to 1. We can say b is equal to 1 at this hazard, and c is equal to 1, right? So how do we write this in equation form? When b is equal to 1 and c is equal to 1, this is also known as BC. BC. Now, if any of these numbers was 0, we just assume it's 1. But if it was b is equal to 0 and c is equal to 1, then it would be b bar c. Because we always assume it's 1, and the bar represents when the variable is 0 when we write it in equation form. So you know that when it's BC, then we get a static 1 hazard of a plus a bar to represent that. Now, we're not done this problem yet, as we only did this equation when it was c, but we have to do the same equation when it's a to make sure there's no other hazards within the c variables as well, right? So let's rewrite that equation at the bottom right here. So we have a plus a bar, and we get c plus a plus c bar. So now we're going to do the same thing again, but this time we're going to do for a. So let's do when a is equal to 0 and when a is equal to 1. And then what do we get? So let's start with when a is equal to 0. When a is equal to 0, we have to do 0 plus a bar, which is 1. So anything that is with 0, the whole term gets canceled, right? It's important to remember that. But because it's ORed with a 1, we know that it automatically becomes 1. So for example, if we were to write this, it would be 0 plus 1 is equal to 1. If that makes sense. Because it's ORed with the 1. Because the a bar is a is 0, a bar is just the opposite. So it becomes 0 plus 1, so it's just 1. However, if it was something else, so it was like if it was 0 plus c or 0 plus b, then the whole term would be 0. Okay? It's only because the 1 is here that it becomes a 1. Alright? So now that we got that, we know that this first bracket is going to be 1. It becomes a 1. Now when a is 0, we get c plus a, so it's c plus 0. Now this doesn't cancel out because we have a 1 here. So then it just becomes c, right? So it becomes c because we already have a 1 here in the first bracket. So we have 1 times c plus c bar. Because c bar doesn't have any a's attached to it, so it doesn't get canceled out. So we have a c bar over here. So then our final answer will just be c plus c bar because the 1 times c gets multiplied. So you get c plus c bar. Now, if you remember from the previous problem that we just did, this is the same as x plus x bar. So this is also known as a static 1 hazard, right? This is also known as a static 1 hazard when a is 0 and when b is equal to 1. So from the start, when b is equal to 1 and a is equal to 0, we get a static 1 hazard, c plus c bar, because that's the same as x plus x bar. And the way we write this is the same as b a bar. Because it's a 0, we can always assume a is 1, and we write it as a bar because a bar is the opposite of a, so the 1 then becomes a 0, so you get b a bar. Now if we go to when a is equal to 1, let's see what we get. Let's see if we get another hazard. So when a is equal to 1, we get 1 plus 0, which is the same thing as 1, right? So we get a 1 here. 1 plus 0 is 1, it becomes 1. Then we get a c plus 1. But c, remember when we said that anything ORed with 1, so c plus 1 just becomes 1, right? So c plus 1 just becomes 1. So let's have another one over here, plus c bar. C bar doesn't get affected, so it stays the same. Now if you go further, we get 1 plus c bar because the two ones multiply each other and it just stays as 1. And then we get this in brackets. And anything ORed with 1, like we did right here in this section, just becomes 1 again. After seeing that 1 plus c bar is equal to 1, this just ultimately equals to 1 at the end, right? And then after seeing that, we can determine that this one has no hazards. Now, what is the final equation with no hazards in it? So we go back to the beginning, right? And we can see our first equation over here, right? So we can just copy that down. Let's go to the bottom and copy that down, right? So our final equation is going to be a plus b a bar ANDed with c plus a, ORed with c bar b bar, right? Now, what do we add here? What changes can we make to make this equation not have any hazards? Basically, wherever we have a hazard, we just copy that same equation. So for example, we have a hazard copied over here, BC. So when BC occurs, there's a hazard. And then we also have a hazard down here when BA occurs, there's a hazard. So basically what we do is just copy it here. So we just OR it with BC and OR with BA bar. So then now we can determine fully that this equation now has no more hazards. And then this would be your final equation with no hazards, making it correct. All right. So if you have any questions with identifying hazards and fixing them, please comment down below or email me and I'll be sure to help you out. If you want me to cover any more topics, please comment down below what topics you want me to cover, and I'll make sure to make a video on them to help you guys out as well. Also, if you enjoyed the video, make sure to like, comment, and share. And also remember to hit that subscribe button as I'm trying to get to 1,000 subscribers. So please help me out if you enjoyed the video. And I'll see you next time. Thanks for watching, guys.